So I believe we are now live. So let me extend a very warm welcome to each of you listening in from literally all over the world. We are so impressed with the level of interest and participation. I'm told by Dr. Porn from our APMEN headquarters in Singapore that there are now more than 1,700 people who are registered. That doesn't mean to say everyone links up eventually. Yesterday, we had about 700 people that linked in to this course. What a wonderful level of interest. So happy to see that there's such a strong interest in this topic. And of those 700, apparently 497 of you uh, filled in the pre-course survey. So we're very grateful for that. That's an excellent sample size that will give us an average level of knowledge that we can compare with a similar test that we'll do at the end of the course. So for all of you, whether you just listening in or whether you helped us by way of completing the questionnaire, we're grateful for your participation. Thank you for that. So we've got another 2-hour session ahead of us, 2 hours, and then midway through, after about 1 hour, we're going to have a 10-minute comfort break, and then we'll resume and Neil will end off at an appropriate time. We encourage you again, if you have questions, remember there's a chat box at the bottom of your screen. I think it's at the bottom of your screen. There's a chat box and there's also a question and answer box, Q&A. By all means, use the chat box to make random comments and say hi, introduce yourself. But for questions, please use the Q&A box. You can imagine with 700 people, we can't really monitor the chat and the Q&A box and extract the questions. So please put your questions in the Q&A box and we'll be monitoring the Q&A box. We can't respond to all the questions. There are too many. But like I said yesterday, we will be collecting all the questions. And at the end of the course, for those questions that we've not responded to, Neil will try very hard and we'll help him with that effort to try and respond to each and every question that was listed in the Q&A box. So please use the Q&A box. There were quite a number of inquiries yesterday about availability of the course. So the course is being recorded and it will be made available very rapidly after the end of this course. It'll be uploaded onto our aureen.org website, the APMEN Vector Control Working Group website. Wulan will put the URL in the chat box, and then you can just copy and paste that URL and insert it into Google or whatever, and you should be able to find the recording soon. I think that's about what I wanted to say. So I'm going to hand over to Neil, and I think all of you will agree that Neil did a wonderful job yesterday. So we can look forward to more of the same today. So over to you, and thank you, Neil.
Hey, everyone. Good morning, afternoon, evening, whatever time it is, wherever you are. It is just midday here in Indonesia. So I'm going to be sharing my screen. And here we go. I hope you all can all see the screen. So yesterday, we went through a couple of basic ideas about how to look at entomological surveillance. And the first thing we wanted to do was to identify a question. And today I have 3 presentations. After each one, I can stop and we can take a few questions. We will have the break in the middle, as Leo mentioned earlier on. But in the meanwhile, here's my first presentation on identifying priority program questions. So this first presentation, we want to understand the rationale, as in why we want our entomological surveillance to be question-based. Why do we need to have a question? And also understand how to identify and formulate a question that is relevant, that we can actually make evidence-based decisions from. And at the bottom of the slide, you can see the different parts of the ESPT, the entomological surveillance planning tool. And the first part is, what is your question? And that is where we are at. And we will go through each one of these sections today and tomorrow. Today, we will go over what is your question. We will go over indicators, and we will go over sampling methods. Tomorrow, we will go over the next three. So why should we conduct question-based entomological surveillance? So for everyone who is in a program, I'm sure you know you all collect a lot of data routinely, species composition, where they are, when they are, what they're doing, and how much of that actually goes to programmatic decision making. The objective of entomological surveillance should be providing evidence so that we make appropriate decisions, and the appropriate decisions will enable us to protect people better. Correct? That is what entomological surveillance is to me, especially for a program. So when we have a question, right? When we have a question, and for example, the question is towards making a decision. Let's say the program wants to understand if they should implement IRS in a location. That is a really good question. Should we implement IRS in area A or area B? That's a really good programmatic question. And based on that, entomological surveillance can provide the evidence based for if IRS is a good idea to implement in that area. And your question that you ask will directly inform, it will tell you everything about your entomological surveillance. It becomes more focused, it becomes more directed. And you know at the beginning of your surveillance, when you start your surveillance, what your objective is, instead of just collecting and amassing all this data. Your surveillance question will tell you what indicators you use, what sampling methods you need, what your surveillance design is, your sites. It'll direct everything. So once you have a question, you've basically started off on the right path. You know what you're going to do. So this is the first step in designing a suitable and effective entomological surveillance plan. Oh, next slide. Yeah. So when you're identifying a question that you want to ask, let's say just for an exercise, or if you have to figure out what to do for entomological surveillance for the next year, try and consider these things. For example, epidemiological data. Since we're looking at disease, you might want to look at areas where there are outbreaks, or if there are sudden risk factors, if migrant populations are coming in, and you might have a question about that. Should we implement bed nets with these migrant populations? And that would be entomological surveillance would help you answer that question, right? For example, if you want to understand if you need to change your active ingredient, should I switch from normal pyrethroid bed nets to PBO bed nets, right? That's a very specific question, and a lot of people are asking that. That is a good question to ask, and your entomological surveillance will directly answer that question, right? So there are many different kinds of questions, and I'm going to go over the 6 themes that the ESPT has. And these next slides are not directive, but they're just sort of giving you an idea of what kinds of questions you can ask and how entomological surveillance can answer them. The first theme is to evaluate what your present strategy is. Can we use entomological surveillance to evaluate how our present interventions are performing? And sample questions, and please note that all these questions are completely different questions, and you'd probably need different indicators and different strategies, but there's a lot of overlap as well. So an example would be, what is the baseline vector composition, distribution, and behaviors in an area where we have, let's say, IRS? So we already have IRS there. We want to understand what is happening with our vectors. And let's say the decision we want to make is, should we continue IRS? Or another decision we might want to make is, should we change your IRS active ingredient? Should we change the insecticide? And this question would be able to answer that, because we will know if our vectors are actually impacted by the IRS at present. We will know if their behaviors overlap with how IRS functions. We will know where the gaps in protection are. And I'm hoping you can relate everything I'm talking about today to what we talked about yesterday. And the key points yesterday were minimal essential indicators, as well as gaps in protection, how an intervention is functioning and how it's not functioning. So a question like this would be able to answer, like, should we change our IRS, or should we continue IRS, or should we remove IRS? Another question is, how does my current intervention strategy affect malaria populations? And that would be associated with malaria epidemiology, how much malaria we have there. Let's say malaria has gone up at our site, right? So we'd want to understand why. That's another section, but if does our present intervention impact our vector population? That's a good question to ask too. Another one is, are local vectors susceptible or resistant to the insecticide-based intervention? This is something we do quite often, right? And the decision to be made, the programmatic decision to be made is, should we switch our chemical, our bednet chemical or our IRS chemical? Another question is IRS effective in area B based on vector behavior, vector human behavior, and insecticide susceptibility? So now we look at a bunch of drivers that can impact IRS, and we want to see how effective IRS is at that site. So these questions, these are example questions that can evaluate our present strategy in place. The second theme is, how do we select an intervention for our site, and probably maybe even a supplemental intervention? So let's say our site has an intervention and we want a supplemental intervention. Should we add larviciding to our site? Should we add IRS to our site with bed nets, right? Or if our sites don't have interventions, or if it's like a new area where no one's ever implemented an intervention before, what intervention would be best for that site? So here are questions that would answer that. What is the baseline vector composition? What is happening as a baseline? What are the vectors doing? Where are the gaps in protection? Where are people being impacted, right? So we can understand if our interventions and what intervention would function best in that space. And that is also associated with the second question listed, which is, what are the gaps in protection? And what are the available interventions that can address these gaps, right? So we can implement the most effective intervention. Then where and when should a supplemental intervention be deployed? That's an example question as well. And also, how do vector populations change after a supplemental intervention is introduced? So let's say we have bed nets, and now we want to put in, let's say in the picture, there's someone doing larval sampling. So let's say we want to look at larviciding as a supplement to bed nets. Do our vector populations change after we put in larviciding, right? So that's a good question as well with our supplemental intervention. Drivers of malaria transmission. We want to understand what is supporting malaria transmission, what is driving maybe an upsurge of malaria transmission, what is driving residual transmission at our site. And a couple of sample questions are, what are the entomological drivers of transmission in our area? And this could be based on vector behaviors, vector species, it could be resistance, it could be a bunch of things. As well as, suppose humans are actually a driver of transmission, we'd want to understand that. Suppose humans are not using their bed nets, or what if humans are all sleeping outdoors at night without their bed nets, right? Even though we have bed nets there, the humans are actually, their behavior is driving transmission. So we can actually evaluate that with a question as well. And then we can look at, if we're looking at things that are associated vectors, for example, rainfall, right? Malaria incidents, right? All these things. How do these support malaria? How do these drive malaria at our site? So another thing we can actually find out from this is the timing of intervention deployment based on IRS, right? We want to put in IRS right before a surge, the mosquito population surge, before, so we can control those populations. We can even look at that. What is driving transmission at our site, so we can place an intervention in time to curtail or slow down that transmission. The fourth one is something that people don't think about too often, but it's actually really important. And I'm sure everyone in the program knows how true this is, right? Where we have limited funding or limited capacity, we don't have enough people, we don't have enough cars, we don't have enough funds, we don't have enough CDC light traps, right? So what are the priority entomological surveillance activities we have or we want to conduct when there's not enough funding? That's a really good question. And we can actually use the ESPT to answer that question. What are the minimal essential indicators, right? We don't have to collect all the data possible. What are the minimum essential indicators that can answer our question, that can inform our strategy? That's a good question too, especially with limited budgets. And what entomological surveillance activities can be conducted with our current program? So how do we maximize the output, maximize the how productive our entomological surveillance can be with our current budget? So you can move through the ESPT, you can figure out all this and report back to your bosses like, hey, this is the most we can do, right? I hope these sort of questions help you try and see what kinds of questions we can ask. For some of your sites, you might have eliminated malaria. And I think there was a question about that yesterday. Or malaria is super low. Or let's say there's a tsunami or a typhoon or a cyclone. And you have all this water, and maybe mosquito populations are going to rise hugely. There's a change in receptivity. There are invasive species, and you've almost eliminated malaria. What do you do? How can you combat that? So you can actually look at specific questions that deal with changes in receptivity, right? So you can look at how do vector populations change over time in areas when you're trying to prevent the reestablishment of malaria. That's an entomological surveillance question, right? How do these changes increase the potential for malaria transmission if imported parasites were introduced? So, for example, you monitor your vector populations over the year, and then you notice in May and June, your vector populations go up. And now you want to make sure that you don't have migrant populations with malaria coming into those sites. So you increase your surveillance for that, just so that you are informed and you can be more careful. That was just a made up example I just made up, right? And then let's say there are critical changes in receptivity in area A, like, a storm or a typhoon-based water sources. Now, all of a sudden, there are a bunch of larvae everywhere. Like, you can use entomological surveillance to monitor that and implement responses. And the last one sort of is everything else that fits under an umbrella that doesn't fit under the previous sort of themes. And these are questions that are very specific to what your needs might be. For example, can a CDC light trap serve as a proxy for human landing catches for HLCs? And this is a question that actually we had to ask in Namibia, for example, where I thought completely wrong, I was completely wrong, that we could use CDC light traps because it was a little difficult to get HLCs approved, and we used CDC light traps. And we didn't catch any mosquitoes, barely any mosquitoes. And so we thought, like, hey, let's evaluate CDC light traps next to human landing catches, because either there are no mosquitoes and we're not catching them, or there are mosquitoes and CDC light traps are not catching them. And so we used HLCs with CDC light traps, and we realized that CDC light traps were not catching the vectors. And the human landing catches immediately caught a bunch of vectors, including Anopheles gambiae, which was not documented in Namibia for years and years and years. So we actually evaluated what trap was most suitable to catch the vectors there. And that's a really good question. It's part of entomological surveillance. We can ask questions like, can we rear insects for specific species for insecticide resistance testing, as well as what's the most effective tool for collecting specific species of mosquitoes in specific sites. And this is actually an important question to do, because as you know, different species have different behaviors. And what's more frustrating is that the same species in different areas will have different behaviors. The same species has different areas based on where they are. I hate that because they totally mess up everything. So a lot of times, if you implement one trap in one site, you can catch a bunch of anopheles, and you implement the same trap in another site, and you won't, even though there are lots of anopheles there, because those mosquitoes there decided that, hey, we're not going to be trapped by CDC light traps. So these are questions we can ask with entomological surveillance and use the ESPT to answer these questions. Your question again directs everything. This is I think it's the last slide on this short presentation. But yes, your question is important. It directs everything. And please think about a question or two or 10 that you would like to answer or think about and over the next few days and try and apply what we are doing to that question. Uh, and just as a reminder, by tomorrow, if possible, if you could please download the ESPT. If you look at the recording from yesterday, you can see how to do it. All you have to do is Google ESPT MEI, and you should be able to download the PDF version of the ESPT. And the little ESPT, or the electronic version of the ESPT, is that we can work through. We will work through this on day 4 on Thursday. And please take the time to download it. It will be very helpful for you, I feel. So think about your site and what kind of questions you might have. And also, yesterday, a couple of people emailed me. Thank you very much. If I am speaking too fast or too slow, please let me know, because I need to adapt to make sure that I'm functioning well for y'all. And that is the end of my first short presentation today. And I was wondering if there was any questions I could answer before moving on to the next one.
Neil, I've been
Yes.
trying to respond to questions,
Oh, thank you.
but maybe, if you wouldn't mind, there's a lot coming in.
Ah,
So maybe go to the top of the Q&A box and just do 3 questions, and then we move on again.
what is the minimum concentration of parasitemia in a host to get mosquito infective for all human malaria? Oh, whoa. So I think the question is, how much parasitemia does a person have to infect mosquitoes? There are studies on this, and I think 1 or 2 parasites can actually infect a mosquito, though more are usually better to infect. There is data on this. If you look at PubMed, you can find answers to that. In some countries, interventions are carried out without baseline. You are completely correct. And this is sort of conventional, right? I was talking about yesterday about the WHO guy who said solution implementers versus problem solvers. And this is where we're trying to implement a solution without trying to understand the problem. And a lot of times this works really well because WHO actually has really good evidence that says that bed nets work, right? So if you just implement bed nets, the assumption is that all the evidence that WHO generated will actually produce good results. But this is not applicable for all sites, and it doesn't mean you're going to eliminate malaria. So understanding a baseline of what's happening or conducting entomological surveillance to find out what's happening now, even if you don't have a baseline from before, what you do now can be a baseline, and you can make better decisions moving forward. I hope that answered that, or I agree with you. Hopefully, there can be better decision making moving forward. What is suitable, Ella lines or IRS, especially in hot weather areas? So Ella lines and IRS both function completely differently. So for me personally, I would not look at hot weather areas, even though hot weather can impact how humans use bed nets. For example, I find it impossible to sleep under a bed net when it's really, really hot, right? But if I'm looking at the vectors, what I would do is try and find out if my vectors are resting indoors on walls. How do the interventions function, right? If they're resting indoors on walls, then IRS is probably going to be effective. If they're biting late at night and indoors, then Ella lines are going to be effective. But just as you mentioned, hot weather, you want to factor in what humans are doing. Are they sleeping outside because it's too hot inside? Are they using their bed nets, right? So that's an important factor too. So you'd want to consider what the humans are doing, what the mosquitoes are doing, and how the intervention functions.
All right. Thank you, Neil.
Oh, okay.
Yeah, please continue. We'll get back to these.
Questions, yeah. Too
Yeah,
many
thank you.
questions. Yeah.
Yeah.
As a note, yeah, questions are a very, very good thing. So I'm really happy there are lots of questions. And we do have a plan to try and get them all answered, but we will collect them and sort of because there's so many, we'll put them into buckets and try and answer them over time and post them somewhere. But we will get to that. I will get to that too. We will all get to that. So the next presentation is on selecting minimal essential indicators, right? So now the learning objectives for this set of slides is how to select your minimal essential indicators to address the question. A second part of this is human behavior observations, and these are so, so important. And I am going to go over this in a bit more detail, and hopefully you will realize how important it is. and then also how to integrate multiple kinds of data. There's just a couple of slides on that. It's more conceptual, but these are the three things we'll go over in this presentation. So in the previous presentation, in the last 15 minutes, we went over what is your question. Now that you have what your question, now that you know what your question is, we have to select the indicators that will answer the question. So in the ESPT, this is where we are right now. So what is an indicator? An indicator is a specific, observable, or calculatable metric to measure the status or level of an outcome and generate an actionable response. That was a lot, a lot of big words in a sentence that I cannot repeat myself. So it's basically something you can measure, something you can measure that answers your question. It is quantifiable. We usually calculate this by species, for example, the Anopheles gambier biting rate, or location, for example, indoors versus outdoors, and by date and time. For example, the biting rate between Anopheles gambier biting rate between 6 and 7 in the evening, or the Anopheles gambier biting rate by night. We can also do it by space and by time and variations by season. So we can calculate all these indicators based on your question, right? So we can calculate the human biting rate by the rainy season and the dry season, by species, by indoors versus outdoors versus in the forest. So, but we can measure it, right? The key point is that it's quantifiable. So that's an indicator. What is a minimum essential indicator? This is an indicator that is essential to correctly measure an outcome. It's essential, like you need this, and without it, you will not be measuring or doing a good, you would not be doing justice to your question. So when you select minimal essential indicators, why? Why should we do minimal essential indicators instead of just collecting whatever is out there, whatever indicator list we have of 20 indicators? And the key reason is that every indicator you collect costs money, right? And every single program has limited funding. We do not have a ton of funding. So by collecting minimal essential indicators based on a priority question, on a chosen question, we can direct what we are doing, focus all our efforts into something that we know what our outcome is and how we're going to use that outcome, instead of having a whole bunch of data on my computer or someone else's computer, right? Collecting data nonstop and a bunch of it is not sustainable, right? We can tailor what we do to our specific needs, to our country needs, to my program needs, to what's happening at our site. So the main thing is it impacts funding, how much money we have and what we can do, right? And if you look at the ESPT, if you've downloaded the ESPT, in tables 1 to 4 in module 2, if you just look through this, remember you're going to get all these slides and everything. You can take your time or do it this evening or whenever you want. There are indicators of vector control, human behavior, and risk factors as well. So how do we select indicators? The first thing we select this indicators is based on your question. That directs everything, right? So you figure out what your question is and figure out your indicators that answer your question. It is really important to know or realize that you don't use the same indicators even though your questions are slightly different. For example, your baseline indicators for understanding if an intervention will be useful are not the same as understanding intervention impact, which are not the same for understanding when you take out your intervention, right? So your indicators you would use to answer your questions are completely different based on your question, even though these three things sound similar, right? Intervention potential, intervention impact, and intervention withdrawal. Three slightly different things, completely different indicators. It's important to realize that some indicators can serve multiple outcomes. For example, what I mean is actually some of the sampling measures, or you can use entomological surveillance to collect multiple indicators. For example, if you're looking at indoor resting density, which is an indicator, the indoor resting density, we can also look at other indicators like species compositions, species occurrence, right? We can look at the number of species that are resting indoors. That's another indicator. Or the number, the densities of species that are of each species that's resting indoors. And by season, is this species resting indoors in the rainy season? Is it resting indoors in the dry season? And the key point is that we're looking at indoor resting density. We're not looking at outdoor resting density. We're not looking at the mosquitoes that are not resting indoors. So understand what your indicator actually does and what questions it could potentially answer. So we need to adapt our indicators based on the question. And of course, this can change over time. And some indicators require analysis in lab. For example, when you're looking at the human biting rate in your mosquitoes, you need to analyze the blood in your mosquitoes in lab for the host, what host it was. The same thing with sporozoite rate and entomological inoculation rate, EIR. So I'm going to go through a bunch of indicators, and hopefully we'll have a couple of stories about some of them that are interesting. So the indicators for mosquito adults, and this sort of looks at relative species composition, seasonality, and densities of each species, right? We can use these indicators to understand when to implement our intervention. We can use them to detect invasive species. That's a very specific question if you're thinking about things like Anopheles stevensii. We can look at the impact of vector control, VC is vector control, on different species. That's an important thing because the ones that it doesn't impact will result in gaps in protection, right? Usually it's expressed as the mean number of that species by the sampling method, by house per night, but you can also do it by house by hour or by, depending on what measure or what your question is, right? We can also factor in lab analyses like parity, where you dissect your mosquitoes and find out your age structure of that species, sporozoite rates, the infection rates of that species, as well as sibling species. For example, Anopheles gambiae sibling species. You can look at, do I have Anopheles gambiae? Do I have Anopheles arabiensis? Which of those sibling species do I actually have in my collection? On the right, we have a couple of pictures from different sites. Some of you might recognize your sites. For example, the top has the green and the blue. On the right, you have most 58.2% of them were Phonestis, and on the right was mostly Anopheles gambiae SL, which is maybe multiple sibling species in there, and a very small proportion of other species. So you can see primarily 2 species. In this red and blue one, you can see Anopheles gambiae SL in red and Anopheles phonesis in blue. And you can see different sites have different compositions of these 2 primary vectors. And that's important to realize because suppose your Anopheles phonestis bites indoors and loves biting humans, and your Anopheles gambiae bites indoors and outdoors. So you can imagine an indoor intervention would work really well on your indoor biting mosquitoes and less well on your outdoor biting mosquitoes. Now, what if your Anopheles gambiae SL was actually Anopheles arabiensis that like biting outdoors? Now, all of a sudden, you have 6 sites, some where your mosquitoes prefer biting outdoors, the blue ones, and sorry, the red ones, and some where the mosquitoes prefer biting indoors, which are the blue ones. So at this site out here, your indoor interventions are not going to be that useful. And at this site out here, your indoor interventions would be much more effective. Then, of course, you can reach other sites like this very colorful pie chart over here, where you can have a whole bunch of species with a whole bunch of behaviors that will drive you crazy. And even though they may drive you crazy, they will produce pretty pie charts. So other indicators can be used to assess the impact of vector control, right? And these are indicators like changes in species composition, changes in species behaviors, and changes in insecticide susceptibility or resistance. Now, I'm sure all of you all remember, I hope you'll all remember the talks from yesterday where we looked at when we actually implement an intervention, we change transmission. And when we change transmission, the 3 things we change are species composition, species behaviors, and insecticide resistance. So those are the 3 things we would primarily want to look at when we're trying to assess if our vector control had an impact on our species, on our vectors. We'd want to use different indicators for different interventions based on how the intervention functions. For example, with the IRS, which is indoor residual spraying, and ITNs, which is insecticide-treated nets, we would probably look at densities of each species and exposure rates. Exposure as in like how much exposure to biting is happening with humans. And I'll actually go over the difference between exposure and biting rates in another presentation. So we'd actually look at these with regards to these interventions. With larvae, we would look at occurrence and presence. Are our larvae present in the sites we treat? Are they actually there? Biting is important. The biting rates or exposure rates are important for bed nets and IRS. Resting is important for IRS because that's how IRS functions. IRS functions on indoor resting mosquitoes. Seasonality is more important for IRS than ITNs. And I put a question there because normally I'd ask this question, but with 700 people, I don't think we can. So seasonality is important for IRS because the timing of IRS, when do we implement our IRS, is really important. So we want to look at the seasonality of mosquitoes so we can implement IRS at the most effective time point. Habitat availability is important for LSM, for larval source management. Even though we expect changes to happen with our vector control, we need to realize that changes can occur even in the absence of vector control. And these are things based on agricultural practices. If people use the land differently, they cut down forests, right? Climate change can drive impacts. So multiple things like this can drive impacts. Invasive species like Anopheles stevensi, right, can also have changes that we're not expecting. So indicators, I'm going to go over a couple of indicators over here. And please note that all this will be shared with you. So I can go, I think I can go over it pretty quickly so you all can look at it at your own time. So here are some adult fin indicators and some intervention evaluation indicators, all listed out here. So vector species is one of them. Its definition is vector species in an area and the proportion of overall abundance, right? And the calculation is on every slide. So I'm going to skip the calculation because I'm sure you either know it or you can just reference it because me saying it won't make much of a difference unless you have a question about it. So over here, we'd look at the vector species and how much of each one there is. And I use that same example from Sulawesi down here, where we have a whole bunch of mosquitoes that resulted in a pretty picture. Why is species composition important? If you remember our slides from yesterday, where each species has different behaviors, and each behavior dictates where and when transmission happens, and each behavior dictates how effective our interventions are going to be. And the changes in behaviors by species further messes everything up and complicates everything. So understanding what happens with our vectors and our species compositions is actually pretty important for a program. This is a model-based output from Marianne Sinka and just tells us the primary vectors, model-based primary vector across the planet. And we can see a whole bunch of them. However, even though you look at this picture and you're like, whoa, there's Syndychus SL in the island of Java over here, where I am right now. And when you actually go to the site, even though modeling says this is the primary vector, you will find a bunch more vectors there. For example, if you remember, I talked about Sulawesi, which is this blue one over here, and it says Balabacensis. If you remember the previous slide, all these are from Sulawesi. So understanding your species composition is actually pretty important. And an example is in this picture. This is data that I made this graph from data from Kenya. So Kenya has at this point in time, we look at three primary species. There's Anopheles gambi that likes biting indoors, feeds more on humans and less on animals at this site. Phonestus loves biting indoors and feeds mostly on humans, loves humans actually. Arabiensis, Anopheles arabiensis, fed more outdoors and mostly on animals. You can see, the gambi was most of them. There was less Phonestus and even less Arabiensis outdoors based on the sampling measures used. There's about 80-90% of malaria a while ago, which is a lot of malaria. Bed nets and IRS were implemented. Malaria went down, thankfully, and it's still down a lot. But what happened to the mosquito species? The ones that were indoors, Anopheles gambi, and biting humans, basically their populations crashed, the green and the red. The red actually disappeared for a while. The mosquitoes that loved biting indoors and loved biting humans disappeared because your intervention overlapped with their behavior so much. The green disappeared so much. The blue basically remained the same because they were biting outdoors. They were feeding outdoors. They were not that impacted by the malaria. And what you see is malaria crashed, and then it sort of stabilized and hung out for a while and didn't change at all because our intervention worked as much as it could against the susceptible vectors. And the vectors that were refractory, that had behaviors that let them be refractory, that let them avoid the intervention, basically survived and continued transmission. And 25 to 30% of malaria of population with malaria is a lot of malaria. And right now, unfortunately, this line is going up. And these two species, the green and red one, have come back because of insecticide resistance. So now we have resistant mosquitoes and the populations are going up and malaria is going up a bit too, which is unfortunate. But that's why understanding these species are really important. And as a note, I'll come back, if you remember this specific example, I have another slide that looks at this slightly differently in another slide or two. Here are larval habitats, right? This is the proportion of habitats with Anopheles larvae. And of course, this is associated with larviciding, or for example, if you're collecting larvae for insecticide resistance tests. Here we were doing larval sampling in Halmahera, if I remember, which is eastern Indonesia. And we were trying to understand which sites to treat. And what was interesting is that the people in this site, we found larvae in the sites with ticks in them. We did not find larvae in the sites with X's in them. And without this surveillance, we would have never known this is where we found larvae, because where people were treating were basically these ditches, which is site number 9. They were treating these ditches, and sometimes we were treating these permanent pools, which was 19, and there were no larvae there. We found larvae in other sites. So knowing where your larvae are important. Receptivity is basically the presence of your Anopheles, if there are any Anopheles larvae there, usually done with larvae. And that will tell us if that site can enable transmission of malaria. This is important for this indicator is important when you're looking at elimination, right? You've eliminated malaria, but you still have vectors there. So you have the potential to carry malaria, to transmit malaria there. Seasonality is the season of primary malaria transmission. And in this figure, you can see on the left is the total number of mosquitoes collected, and this is each month. And blue is the number of mosquitoes you collect, and orange is the rainfall, and you can see that's your malaria transmission season. So when you know this with your entomological surveillance, you'll know when is the appropriate time to put in your intervention, when is the best time to put in your intervention. That's your rainfall. Rainfall is a driver of your mosquitoes over there. I forgot to mention that. With data like this, you can actually look and see what is driving your mosquito populations. And over here, it is rainfall. Endophagy versus exophagy. Endophagy is mosquitoes that feed indoors. Endo is indoors, and phagy is biting. Exo is outdoors, and phagy is biting. So indoor and outdoor biting. This is important because we can understand where and when mosquitoes are biting humans, and where our interventions would work better. If you remember the previous example in Kenya, where mosquitoes that bit indoors were affected mostly by the interventions, and that amount of malaria came down based on that level of protection indoors. So understanding indoor versus outdoor biting is important. We can also look at evaluate mosquito biting rates in forests, so in other areas where transmission may occur. And recently, there's evidence that there is transmission happening in villages, in the village bar, for example, where people go hang out late at night and they're drinking and they're getting bitten by mosquitoes and getting malaria, and then going back home and sleeping under their bed nets, but they already got malaria outdoors. So those are also transmission sites. So it's domestic, indoors, peri-domestic, which is right outside the house, and possibly call it extra domestic in the village, outside the household. And here are why mosquito behaviors are important. This is a slide from a publication by Nabi Bio from Kenya. This is the exact same data that I made a graph of earlier on. And you can see this is proportional amount of species. Initially, indoors, they were the primarily Gambiasis, and there were a lot of Gambiasis and a few Arabiensis. And you can see Gambiasis like biting indoors and humans, and Arabiensis like biting outdoors and cows. And when you put in your bed nets, the Gambi populations went down, and proportionally, the Arabiensis populations went up. And so over time, they were finding initially more Gambi in their collections and less Arabiensis. And after bed nets, it switched. They were finding very few Gambi and a lot of more Arabiensis proportionally, right? I hope that made sense. the biting time, when and where, when a mosquito is biting, early evening, middle of the night, or early in the morning. So when it's a primary time of biting, and the left, here's a graph. On the left is the human landing rate, the number of mosquitoes per person per hour for that hour. And here's 6 p.m. to 5 a.m. And you can see you can see the indoor landing rate, which is in blue. You can see the landing rate goes up over the course of the night. So most of the biting is happening at about midnight. And outdoors, most of the biting is happening early in the evening. And you can see people will probably be getting exposed to malaria early in the evening outdoors and in the middle of the night indoors. And an example is from the Solomon Islands. And this is actually super interesting to me because we actually document changes of behaviors. There were 3 species of mosquito there, Pharauti, punctulatus, and coliensis, very similar to Kenya, where Pharauti liked biting indoors, outdoors, and liked humans. Punctulatus bite indoors and outdoors, but mostly bit humans. And coliensis loved biting indoors and was anthropophilic, loved biting humans. Uh, in June of 1917, all these mosquitoes were biting indoors in the middle of the night. This is the biting rate. This is the middle of the night. This is 6:30 in the evening, 6:30 in the morning. They implemented DDT, and by September 1972, the mosquitoes were biting in the evening, not in the middle of the night. They changed their behavior. And so what happened was they asked us, a team of us, Tom Burkhardt, Tanya Russell, a bunch of us, to try and figure out what's happening. And this was maybe a couple of years ago, maybe 8, 9 years ago. There are publications in it you can look at. And we went out there and actually documented what these mosquitoes are doing and when they were doing to find out what's happening now. And what we found is in Central Province, Anopheles pharauti was the only species left because the other 2 were basically killed off by bed nets and IRS because they were susceptible. What we found is mosquitoes, Anopheles pharauti, were biting indoors in the evening and stopping biting later on. And they were biting, a ton of them were biting outdoors in the evening. And what we realized is that indoors, we have our bed nets and our IRS, but all the mosquitoes were biting outdoors. 84% of biting was happening when people were outdoors and unprotected. And the ministry wanted to know if they could eliminate malaria. And even though IRS and bed nets would be impactful, would impact mosquitoes that were biting indoors, which would be that small percentage of 16% or slightly more than that, it was insufficient to eliminate malaria in this area. And right now, as of right now, I think malaria is going up in that region, and we're trying to understand why. Indoor resting density, the proportion of Anopheles resting indoors by vector species. So this is important for a specific intervention, and that is IRS, right? So we want to understand where our mosquitoes are resting and if they're going to be impacted by IRS. There is a very specific example that I've saved for later that was actually totally cool to me, and it was a lesson learned that I learned and try and apply to my work, but I'll get to that in a bit. Then we can look at insecticide resistance, the amount of susceptible mosquitoes versus resistant mosquitoes. There are specific methodologies to do that. We can use the WHO bioassays or the CDC bottle assays based on the insecticide you want to use. And please note that this should be species specific. If let's say you collect Anopheles gambiae SL, which is a species complex, and you do your Anopheles insecticide resistance tests, and you find out that it's resistant, but you don't know the specific species, I honestly don't believe that's good data. Because let's say you have Anopheles gambiae, which feeds indoors, and Anopheles arabiensis that feeds outdoors. Your resistant ones might be gambiae, and your susceptible ones might be arabiensis, which means your resistant ones are not being impacted by your intervention, and your susceptible ones are not even exposed to your intervention. So understanding your species relative to your insecticide resistance is actually pretty important. So when you're looking at vector control products, there are also indicators there. These usually directly evaluate your vector control product. There are bioassays, and you can do this at multiple time points through the year to understand how long your intervention is effective. For example, down here on the right, they're doing wall bioassays, wall cone assays, to understand if the IRS conducted that site is still effective. There are standardized methodologies. They're available at WHO. There are things like looking at the physical integrity, if there are any holes in there, if people are using them, throwing them out. You can use cone bioassays using susceptible and resistant mosquitoes. There are multiple indicators that go along with this. For example, percentage knockdown, KDs knockdown, the number that die, the blood feeding index. You can even look at the chemical content of the active ingredient that was sprayed or on your bed nets, right? We need to definitely do this for IRS to understand how long it lasts, because we want to make sure it lasts throughout the transmission season. Yeah, so these indicators for vector control products are not necessarily entomological, but they're still super important. We need to do them because we need to understand, for example, the coverage of bed nets, the coverage of ITNs, the proportion of houses that were actually sprayed, right? If you spray 10% of your houses and you say I've given IRS to my geography, but it's only 10%, you're not going to have a big impact. And that can completely impact how we look at the intervention. If you don't spray enough, if you don't distribute enough bed nets, you'll think it didn't work when actually you didn't do a good job of distributing it or giving it to enough people so that it would work. So it can be operationally oriented. For example, did we spray the houses well enough? Did we have the correct sprayers? Did we do a good job of actually implementing the intervention? And that is process evaluation. Or we can look at the population what was the coverage of the population, right? And then we can also look at the number of people sleeping under a bed net. And there are specific indicators to understand how well we implement and how well the intervention is used, right? Overall, we want universal coverage with the right intervention in the right place. That is our objective. We want the most appropriate intervention that matches with our humans and our mosquitoes for maximum protection. Some of these specific indicators are bioefficacy of interventions. And so we'd use susceptible mosquitoes to see if we can actually kill them or knock them down. For example, using a fresh bed net or a 1-year-old bed net or a 3-year-old bed net, we can understand how well it's effective against those susceptible mosquitoes. Intervention coverage is a proportion of your population with the intervention. For example, for bed nets, you need it to be at least 80%. We want it to be at least 80%. Ideally, everyone would have a bed net. Intervention usage, the same picture with a little kid sleeping with not under a bed net, but are you using your bed nets? You can give everyone a bed net, and if no one uses it, it is of no use. And here we go. Here's something that I think is important. I'm going to have a sip of tea. Besides mosquito behaviors, what is a huge predictor of intervention success or failure? And this picture should tell you what it is. The little kid is sleeping outside the bed net. And this is human behavior. Human behavior is so important for vector surveillance, and often we don't do it. The definition is the characterization of human behavior that impacts transmission and intervention effectiveness. And an easy example is bednet usage. I think I mixed up my slides. Hold on one second. So when we're collecting, I did mix up my slides, but that's okay. When we're looking at these indicators and we're looking at minimal essential indicators, I know you remember this from yesterday. When you're looking at IRS, the minimal essential indicators are those two, based on how IRS functions, into the residual spray functions. But we can also collect other indicators. It's the same thing with bed nets. But how do bed nets function? On indoor late night miting mosquitoes that are susceptible, and we can collect other indicators as well. For larval control, it's just which habitats we treat. And we can collect other ones as well without any extra cost. And these are the three things we want to monitor when we follow and when we implement an intervention so we can follow changes. I'm repeating these slides from yesterday because it's just so important to me. If you go to the ESPT, Table 1 has minimal essential indicators that we think are minimal and essential entomological. Table 2 has supplemental entomological indicators. Table 3 has vector control performance indicators to evaluate vector control. And table 4 has human behavior and risk factor indicators. Here's an example from table 1. For example, it's on page 9 of the ASPT, if you have it with you. Occurrence, here's the outcome of it, and this is why it's important. So, for example, for occurrence, it's the adult female vectors present or absent, and it's important to know whether your site is receptive. It's important to know because you can detect invasive species. You can determine vector species compositions and seasonality and monitor the impact of an intervention. So just by looking at your indicators in the table 1, you can understand what it actually is and why it's important. And there are a whole bunch of them. This is just a screenshot from it. And table 2 is the supplemental indicators that are nice to have indicators. They're not minimal essential, but they're nice to have, and they can help you understand things better. For example, understanding the human blood index, right, will help us understand the anthropophagy or zoophagy if a mosquito prefers biting humans or animals. This may not be essential for making programmatic decisions, but it's a nice to have. It's a nice to understand that, oh, this species really doesn't like biting humans, right? It's a nice to have. Table 3 is vector control intervention indicators, and here we can monitor or evaluate these interventions, and they're listed out here. For example, bednet durability, and it's why it's important is on the right, and you can look at the outcomes in the middle. Table 4 is human behavior and risk factor indicators. And again, just as I said earlier on, indicators are on the left. For example, the time to sleep or the time awake, and why it's important is on the right. And feel free to look through these and look through them towards understanding why this is so important. Now, this picture. That is a picture of my leg. So I was in Papua and I was doing human landing catches. And I went a little crazy because in the first 15 minutes, I caught, I think, 40 or 50 mosquitoes, and they were landing on my legs. And while I was trying to aspirate one, another would land. And while I was aspirating that, 3 would land on my other leg. And I was basically frantically trying to collect mosquitoes. And while I was catching mosquitoes on my leg, if any of y'all can see a picture of me, can you see this buffet for mosquitoes on top of my head? They were all landing on my head. So I was literally going crazy, getting chewed up by mosquitoes. I was sitting outside. It was from 1 to 2 in the morning. And I was sitting there thinking, this is crazy. And that's my leg. What happened? What my leg looked like in the morning. I got chewed up. And what I realized was I was getting chewed up. And there was not another person around me. I was doing human landing catches to look at the human biting rate. And if this did not happen, I would have gone home and said, the human biting rate is 350 mosquitoes for 1 to 2 in the morning in this village. All the transmission is happening outdoors. And I would have been completely wrong. Because at 1 to 2 in the morning, while stupid me was sitting out there getting chewed up by mosquitoes, where do you think everyone was? Everyone was in that village. Everyone in that village was asleep indoors under their bed nets, right? So that made me realize I was doing something completely wrong, and I had to get chewed up to realize it. So here, if you look at this picture on the left, you have your human landing catcher indoors catching mosquitoes, and here's me being stupid outdoors catching mosquitoes. And let's say, for an example, between 1 to 2 in the morning, we catch 50% of the mosquitoes indoors and 50% of the mosquitoes outdoors. Normally, historically, we say that the risk of getting bitten is 50% indoors, and the risk of getting bitten indoors is 50%, the risk of getting bitten outdoors is 50%. And I'm saying that is completely wrong just because of what I went through, because this is what happens in real life. The mosquitoes indoors, the mosquitoes outdoors. That people indoors asleep, that people outdoors, they're doing multiple things. And these people indoors might be under a bed net, they might not be under a bed net, but we're doing the human landing catches in those areas, and the human landing catches are not indicative of what's happening to that person in the community. Because remember, stupid me sitting outside alone while everyone's protected indoors. So what actually happens in this example, if the proportion of mosquitoes we catch indoors in the HLC is 50% indoors, 50% outdoors, just as in the previous on the left. But if 100% of your people are indoors, the risk of getting bitten is actually 100% indoors and 0% outdoors. So the risk of getting bitten by those 350 mosquitoes outdoors in that hour was 0% because the community was not impacted. So normal HLC collections and estimations of biting rate are not indicative of exposure, actual exposure to mosquito bites, to malaria. And that is where our human behaviors come in. And human behaviors in our communities that we're looking at is so important because we can understand where and when they're actually getting bitten. And where and when they're actually getting bitten will tell us what intervention works best for them. Because different people, just like mosquitoes, have different behaviors. Different communities have different behaviors. And there are multiple kinds of behaviors. For example, you can have people indoors, people outdoors, families outdoors at different times of the day, people sleeping without bed nets, people sleeping with bed nets, everyone sleeping under a bed net, some people without bed nets, different kinds of exposure. And here's you have someone, maybe that's me, meditating outside, getting chewed up by mosquitoes in the middle of the night. But you can have multiple things happening all the time. And again, your family can leave the house and go live in the forest and get, or be in their farms and get chewed up by mosquitoes there. So understanding where and when people are getting exposed to mosquito bites, their behaviors, is so important to actually understand what interventions work, as well as where your gaps in protection are. So it's super important to integrate your vector and human behavior data to identify gaps in protection. Because just remember, me sitting outside there getting chewed up by a bunch of mosquitoes did not tell me where the community was getting bitten. But the intersection, the overlap between what humans were doing and what most mosquitoes were doing would tell me what was happening. So just remember, vector control interventions target species-specific behaviors, right? And interventions protect humans from mosquito bites when human behavior and the vector behavior targeted by the interventions overlap, right? Remember that? This figure, it's the exact same thing. So we want to understand this intersection because that's where we get protection and that's where we have gaps in protection. And this left green oval is what we need to integrate into all our entomological surveillance, I feel, because that will tell us what we're protecting and what we're not protecting. And whenever you feel that you should not do human behavior observations, just remember my leg covered in mosquito bites and think, okay, maybe I should do it. Because the cool part about human behavior observations is that it is 100% free. It doesn't cost any extra. Actually, you can just ask the person who is, oops, this slide didn't work out. I just ask the person who is doing the HLCs or doing the CDC light traps to collect the data on what people are doing in that hour on a sheet of paper. And we can go over that later on. So this slide ended up a little weird. I don't know what happened to it. But basically we have our three, our intervention, our human behavior, and our vector behavior. That's what happened to it. And how do we actually understand the intersection between all these? So I think the animations went off here. But over here, we can basically look at how the intervention works. Let's say it's bed nets.
Neil, can I
Yes.
just ask you, how long is this particular presentation still likely to go on?
A
Because
couple more slides.
okay,
Yeah, a couple more slides, and then we can take a break. Is that
all
okay?
right. That sounds
Yeah,
good. Thanks, Neil.
yeah. So we have our intervention here, our vector behaviors here, and our human behaviors here. And over here, we're looking at people outdoors, people indoors with bed nets, and people indoors sleeping without bed nets. And then simply overlap the three. Over here, we get protections where people are sleeping under the bed net. And over here, we have people exposed, sleeping indoors awake, and sleeping indoors not under a bed net, and outdoors. And this is the simplest way of explaining how to understand the intersection, how to understand actual exposure, because exposure happens over here and protections happen here. So what human behavior is an integral component of the ESPT, right? And we measure simple things like what time they go to sleep, what time they wake up, the amount of time they spend indoors, the amount of time they spend outdoors, and if they're using your bed nets or not. We usually integrate bed nets into it no matter what. We can do this with surveys or just documenting what's happening when we are doing our HLCs or CDC light trap catches. Yeah. And I'm going to stop now so we can take a 10-minute break. I hope that's okay.
Yeah, thank you, Neil. As Neil said there, let's take a break, give Neil a few minutes to catch his breath, and then we'll resume 10 minutes time. Thank you all for your patience,
Yep.
persistence. Thank you, Neil.
But Yeah, but this is based on HLCs, not based on human behavior. So now we can take the mosquito behavior, which is the red and blue lines, and do a really easy analysis with the human behavior. And this is already published. And if anyone needs to know more about this, please email me and I'll send you instructions and everything. And you can get that. We can look at the exposure based on human behaviors. Now, even though all your mosquitoes are biting outdoors, now remember me sitting outdoors getting chewed up in the middle of the night and no one else around me? It's the same thing here. The red is the behavior adjusted bites happening outdoors. So yes, people are getting bitten outdoors. But more than outdoor biting is the gray, which is people indoors asleep without bed nets. It's the dark gray, which is people asleep indoors and awake. And just the people protected is this crosshatch. So there's so much biting happening outside what people are using bed nets. And you can take all these numbers and make a pie chart, right, to understand the total amount of time or exposure by each of these behaviors. And you can see the red is outdoors. 25% of exposure for this community is happening outdoors. 39 is happening indoors when they're asleep without bed nets. 27% is happening indoors when they're awake. And you're only preventing 8.2% of bites using bed nets. And this we can understand based on looking at your biting rates, which are the red and blue lines, with our human behavior. It's actually super simple. And you can see, even though most of the biting is happening outdoors, most of the exposure to mosquito bites, which is the grays, 27 plus 39, which is 40, 50, 60, almost 70% of biting is happening indoors. And that's exactly reversed, right? If we think of all the mosquitoes biting outdoors, most of them biting outdoors, the red line, but based on what humans are doing, most of the actual exposure to mosquitoes, actual exposure to malaria is happening indoors. And because of that, we can actually look at these spaces and say, look, the people are not using bed nets enough. And this is the exposure, 39% of exposure is happening when people are indoors asleep without bed nets. What if we made them use bed nets? You can reduce exposure by 39%. So just this simple sort of example of actual data from Panama is an example of how to use human behavior alongside vector behavior to understand where and when people are getting bitten. The last few slides on this presentation for integration of data for decision making. So usually as an entomologist, and I assume a bunch of entomologists are on here, we focus on entomological data, right? We also pay attention to epidemiological data, like how much malaria there is. Are there outbreaks? Is it going up or is it going down? As a note, all the people that collect and use epidemiological data, all the physicians and all of them really don't pay attention to our entomological data. They don't. That's just what happens. Uh, Entomology tells us only part of the story. Epidemiology just tells us part of the story. We need to combine our knowledge and what data we collect to understand the picture better. Because when we look at just like including human behavior with our entomology tells us so much more, including the epidemiology with our entomology tells us so much more, and it allows us to make better decision making. So very weirdly, even though us entomologists are focused on entomology, I'm asking you to be a problem solver. I'm asking you to think beyond your box, to make better decisions, to understand systems better, and not just include entomology data, but also try and understand epidemiological data. Because guess what? Your epidemiologist, there's no way they're going to try and understand Anopheles gambiae biting rates, right? Also, rainfall and climate data is important for us to understand. What drives our mosquito populations? Does climate change impact our mosquito densities, right? Our vector control intervention data, that's important for us to example. How do we select our specific intervention? Is our intervention impacting a mosquito population? Was our intervention implemented well enough to impact a mosquito population? Human behavior observations and look at human behaviors. That's so important, as I just described, right? Operational inefficiencies and stockouts, like do we actually have ACTs at our site? If someone comes and tells you, like, hey, there's an outbreak at your site, what's happening with your mosquitoes? And you go out there and look at your mosquitoes and you find there's no difference. What if it's because ACTs were stocked out? There were no ACTs and people were not getting treated. So if you understand that, you can understand the system better because it's not just mosquitoes. And then, of course, mobility of people, human movement, importation of people with malaria, migrant groups coming in with malaria, things, all these things can impact transmission. And we can factor all this into our entomological surveillance towards understanding what's happening so we can protect people better, make better evidence-based decisions. So if you look at table 5, I think this is just going over a couple of tables in the ESPT. You can look at what vector behavior the intervention takes advantage of. For example, an intervention like bed nets takes advantage of insecticide susceptible indoor late night human biting vectors, right? Only when people use their bed nets. So you can look at all these interventions are listed out here, and you can reference them to understand how that intervention works, to see if the behaviors of our humans and vectors at our site overlaps with these interventions. This is on table 5 in the ESPT on page 14. Here's a slide that actually looks over all the different aspects of what happens with the mosquito, right? Let's say we start off with your larval sites and try and look at what interventions work in those spaces and times. So that's larval source management, including larviciding. The mosquitoes emerge, they mate, they swarm, and then they sugar feed, and that's where ATSPs might be effective. And then after sugar feeding, they go to look at hosts, and that's where space spraying or space repellents might be effective. Please note, we've listed out all kinds of interventions here, not just WHO recommended ones. And WHO has a specific list of recommendations. So once you have your mosquito looking for humans, it can try and find people, let's say outdoors or in structures, and that's where bed nets might work, RS might work, space repellents might work, mosquito-proofed housing might work, right? And space repellents might work outdoors as well. And the multiple interventions. You can look at this slide and try and see what works in what space and time regarding the mosquito life cycle, right? You can actually use endectocides to treat cattle. You can also use endectocides to treat humans. And then once your mosquito gets a blood meal, it rests, right? And it rests, and that's where IRS might be effective. And other interventions like up here might be effective as well. It also sugar feeds, where ATSPs can also be effective again. And then when it's looking for an oviposition site to lay its eggs, other interventions might be effective there as well. So this is just a diagram to show you how interventions function with mosquitoes. Obviously, if an intervention functions at more than one point in your mosquito life cycle, it's going to be more effective, right? If it impacts a mosquito only at one single point in its whole life cycle, it's only going to be so effective at that point. But if it impacts a mosquito multiple times throughout its life cycle, it could be way, way, way more effective. Oops, I forgot about all these. I think I said this because most interventions function on host seeking and blood meal. And that's where most of our interventions function, whereas we can have interventions that function in multiple places and times. If you look at table 6 on page 16, we have minimal essential indicators to determine whether a new intervention should be introduced. Will this intervention be effective at our site? And we have, for example, bed nets there. And we have bed nets there, and all the bluish green cells are, you can use those indicators, select those indicators to understand if our intervention, if bed nets are effective at our site. Table 7 on page 17 looks at whether an indicator can be used to evaluate an existing intervention. Is it working effectively? And in the same way, bed nets is right here, and you can look at these interventions out here. So reference a table based on the intervention you have and you want to evaluate, or you're trying to see if that intervention will be effective there. Your selection of minimal essential indicators is important towards answering your question. In fact, how you select your indicators will dictate if you're answering your question correctly. And again, just to repeat, before DDT, malariologists were trained to be problem solvers. That's what we want to be. We want to identify the problem and figure out solutions. And we don't want to just be solution implementers, which is what happened after DDT. People just said, go implement bed nets, go implement IRS. One of the questions in the chat box that I just responded to was, I hope I remembered correctly, but it was when in Global Fund grants, they just say to figure out the API and implement bed nets and IRS there. And that is a solution implementer. It's not a problem solver, right? We don't know how well those interventions will work there. We don't know how effective it's going to be. However, if we looked at our site, if we identified our populations, we looked at the API, we looked at how much malaria there is, and say, these are our target geographies where we want to implement an intervention. And then we look at it as a problem. Where and when is transmission happening? Which of these two interventions that WHO actually allows, Bennett's or IRS, will function best at our site? If all the interventions, if all the mosquitoes are resting indoors, IRS is probably really good if they're susceptible. If none of them are resting indoors, IRS is probably not very good because it's not going to overlap with the IRS. They're not going to be they're not going to be resting on sprayed walls. And if we are just a solution implementer and implemented IRS, we're not going to be doing a good job in protecting people. But if we looked at it as a problem-solving thing, we could potentially hugely protect people much better. And that was my slide set from just that for indicators. And I'm trying to figure out how to stop sharing. Have I stopped sharing? There we go. Before answering any questions and starting up my next slide set. Were there any questions that were pressing that I can answer?
I think we've answered all the questions that have popped up. You get a free ride for now. Next presentation.
Woohoo! Wait, do I get 5 minutes break? No, I'm kidding. I'm gonna have a sip of tea. Or 2 sips of tea. And I will start up again. Okay, where is the Zoom? There we go. Share slides. Okay, my next set of slides is on sampling methods and analytical techniques. And this might take us to the end of today. Wait, can you see my slides? Yes. So the learning objective for this set of slides is understand the good things and the bad things and the limitations and biases of each entomological sampling method, how we actually collect our entomology samples, how we actually collect our indicators, which might not be entomological, they might be human behavior based, and the analysis methods we would use. We will go through how to guide selection of appropriate and available sampling methods to address these questions. Right, you can go through the ESPT, of course, to do this. So in the first set of slides, I looked at what is your question, then we looked at the indicators that would answer the question, and now we're looking at the sampling methods that can collect the indicators that can answer our question. You have to go in that order because you could be using the wrong sampling methods that would not collect the correct indicator, right? So selecting sampling methods, you can start on page 18 of the ESPT, right? So this is obviously, as I mentioned 300 times, is based on your question and the indicators, right? Entomological sampling methods take advantage of specific mosquito behaviors. Just like interventions that take advantage of specific mosquito behaviors, sampling methods do exactly the same thing. For example, when you're looking at a human landing catch, you're looking at mosquitoes that want to bite humans at that specific time, at that specific location. You are not looking at mosquitoes that like to bite cows, for example, right? Yeah, if you're using a cow-baited trap, you're not going to collect mosquitoes that really love biting humans, right? So you need to choose your trap, your sampling method based on the indicator in question. Each method has its positive and negative points and limitations, and it's important to understand that so that you factor that into your analysis. For example, if I use a CDC light trap in an area where I'm not allowed to use HLCs, but my CDC light trap catches are the only data I have, and that's a proxy for our HLCs, for our human biting rates, but it might not be identical to what your HLC data would give you. So you'd probably want to mention we use CDC light traps to evaluate as a proxy for human landing rate, but data suggests that they are not equivalent, that they're not the same, especially outdoor CDC capture rates. I'm sure you'll all know this though. If you look at box 1 of the ESPT, which is on the right, it outlines commonly used sampling methods for anopheles. And if you look at Annex 3, there's a lot more information on each of these sampling methods. The sampling methods we go over HLCs, human-baited traps, and I'm going to go through each one of these one by one, hopefully quickly, because I assume you'll know them all, but if you don't, I'll hopefully spend enough time on them to be able to explain them. Human landing catches. This is considered the gold standard of looking at mosquitoes that target human beings. It's considered the gold standard because you can actually look at the number of mosquitoes that land on a person at that point in time in that location. And here we have old grad student that worked with me, Brandy, in Indonesia, collecting mosquitoes. And you basically wait for the mosquito to land on your feet and you suck them up in this aspirator over here and you place them in these containers and you can have one container for 1 hour so you know the number of mosquitoes that landed on your legs in that 1 hour. You're looking at blood-seeking, human-feeding mosquitoes. And an example of an indicator would be a human landing rate for that hour or for that night. An example of a question would be, what mosquito species like biting humans at my site? Correct? Indoors or outdoors? You can expand on that question. A human baited trap. Now, so human landing catches have ethical issues, as in like because you're using yourself as bait, there's a chance that the mosquito might bite you. And even though there's data that suggests if you treat a person, if you give them prophylaxis, they are better protected than the community. There's also data that suggests that the infection rates if you're not treated, are exactly the same as the community because you're exposed the same amount, theoretically. That paper's on that as well. But the issue comes to non-malaria diseases that are not treatable, like viral diseases, encephalitis, because there are Culex and Aedes mosquitoes that can potentially bite there. So can we protect human beings with the other traps that don't have direct exposure? So for a human baited trap, we would have a person sitting in a mesh tent or sleeping in a mesh tent, and we'd place a larger tent around them. And what happens is the mosquito, here's my cursor as a mosquito, it flies in, trying to bite that person, cannot bite that person, and would land on the wall, or the inside wall of that tent, cannot get out. And every hour we'd walk around and collect all the mosquitoes that were in there. And we'd use that as a proxy. We'd use that instead of a human landing catch to understand human landing rates. And again, the example of a question would be the same. Human landing rate, it's a proxy for human landing rate, or the species that are attracted to humans. In the same way, we have animal baited traps, where we put an animal in, and over here we really don't care. Well, we care, but we don't really care if the mosquitoes bite the animal, so the animal's not under a tent. We're looking at animal blood-seeking mosquitoes over here. That's what this would take advantage of. An example of a question, and here's an example. Actually, both. We're looking at the species that prefer humans versus those that prefer animals. And as you can see, the similarity in the outside tents, they were actually sort of next to each other in the Solomon Islands, where we were evaluating whether the mosquitoes there preferred feeding on humans or on animals. Then we have indoor resting collections, and this is the mosquitoes that rest inside on walls throughout the night, so in the mornings. PSCs are pyrethroid spray catches. I should have put the full form on there. Sorry about that. Pyrethroid spray catches. And we do this by going inside houses and we take out, first of all, we take out most of the stuff that's just sitting around the house. We do this early in the morning. And then we lay sheets out over everything and we'd close up all the windows as soon as we went in. And so we sort of create this bubble and we spray pyrethroid inside there. And we close all the doors and windows for about 10 minutes. And what happens is the pyrethroid should knock down or kill all the anopheles that are still inside the house in the morning. So we go at 7 o'clock, all the mosquitoes that entered that house that night and have stayed in that house and are still in that house, we would be able to collect them all because they'd fall on the sheet. And you can see this guy collecting the mosquitoes that are fallen out there. And endoaspiration is when you go inside the house, inside a hut or a house, and you aspirate all the mosquitoes. And you can do this every hour, every 2 hours. The advantage of an endoaspiration relative to a PSC is that for endoaspirations, you can look at the endo resting rate throughout the night, every hour, and you can catch almost all the mosquitoes that go into a house and rest. And the PSC only captures the mosquitoes that are there in the morning. All the mosquitoes that left before morning, you will not catch them because they're gone. This informs on IRS specifically because we're looking at indoor resting mosquitoes. An example of a question can be the species composition of mosquitoes that rest indoors, right? Or stay indoors till 7 in the morning. CDC light traps capture mosquitoes that are attracted to light. So there's sort of this light structure out here with batteries. There's a fan that blows down here. Yeah, if my cursor's a mosquito, the mosquito is attracted to it, comes out here, and it's sucked down into the trap and is captured in this cage out here. You can place this next to a sleeping human, so use a human as a bait. You can have carbon dioxide to attract mosquitoes. You can use a UV light to attract mosquitoes. You can place this by an animal to attract mosquitoes that like feeding on animals. And again, people use this as a proxy for human landing catches. But it's important to realize that they don't function exactly the same. Sometimes people do evaluations of HLCs relative to CDC light traps next to each other to understand the conversion rate, but it's different for different locations. And a lot of times it's a lot of an issue to actually conduct this. So people conduct this CDC light trap catches where HLCs are not allowed due to ethical issues I mentioned earlier. There's human odor-baited traps or animal odor-baited traps. And you can basically use the odor of your bait, which is a human animal, to attract the mosquitoes. And this is an example of a human decoy trap where there's a little tent and a person sleeps in the tent, or you can put a goat in the tent or something. And there's a fan over here inside that blows the air from inside the tent out here. And the air comes out here. And there's a sticky trap. This is a drum filled with warm water. So it is warm like a mammal. It's dark because anopheles prefer feeding on darker things. And this sticky tape out here. So what happens is the odors come out here. It smells and carbon dioxide comes out here. And the mosquitoes will smell the host, smell the carbon dioxide, and they'll see this warm, dark thing and they'll think it's an animal and come here and get stuck on the sticky trap. And this is a human decoy trap. There are also other kinds of traps similar to that. Outdoor resting collections are where you dig pit traps, where you're looking at mosquitoes that rest outdoors. You dig a hole in the ground and a little hole in the ground, and the mosquitoes would rest there. They work for some species, but not for others. Pot traps are similar to that, where you just plate pots with a little water in them, and mosquitoes will rest there where it's dark and humid. Again, they work in some areas with some species, but not with others. There are multiple types of carbon dioxide baited traps. As I mentioned earlier, you can use the host decoy trap with carbon dioxide in there. You can use a CDC light trap with carbon dioxide. And you can even use like solid carbon dioxide, dry ice. And over here, you're emulating basically a person breathing out or an animal breathing out because we breathe out carbon dioxide. So there's a higher density of carbon dioxide here, and your mosquito will fly along here, come in here thinking there's a host, and then rests on the inside walls of this structure, and you can capture them there. Gravid traps look for mosquitoes that are looking to oviposit or lay eggs. And inside you can actually have double sticky ovitraps. Sorry, I mean, there are multiple kinds of ovitraps, like the mosquito trap, double sticky ovitrap, and large gravid traps. The gravid traps usually work better for Aedes mosquitoes. I haven't used them that much, so I don't have that much experience with them. A window exit trap now actually is placed outside a window, and looks at mosquitoes that are exiting the house. So over here, if you think about mosquito behavior and what advantage this takes advantage of, we are looking at mosquitoes that enter houses in the night and exit houses by the morning, because a mosquito exiting into this, there's a hole over here. Mosquito would come out through the window over here and then would get trapped in this space here. An example of this question would be, what are the number of mosquitoes or densities of mosquitoes or the species that enter a house at night and leave before the morning? So just imagine you can do a PSC, which is a pyrethroid spray catch, alongside a window exit trap, and you can find out all the mosquitoes that rest in the house up till 7 o'clock and in the PSC, and all the ones that are in the window exit trap are all the ones that entered the house and left before 7 o'clock. Here's another window exit trap that is placed outside this window, and this picture is hilarious because I don't know what they were trying to catch, because it would be a rather really large mosquito that was coming out of that window, or maybe they were trying to catch someone who was trying to climb out the window, but it's just two examples of a window exit trap. Then, of course, you have larval surveys, and I use the same pictures as before. You want to look at multiple sites, at multiple larvae, and
Neil, sorry, there's a question here. Would you mind just briefly explaining the pyrethrum spray catch again?
Oh, of course, of course.
Yeah, thank you.
So I'll go back to this. So a pyrethroid spray catch is basically mosquitoes will enter a house to feed on people staying inside the house. And when they're full of blood, usually they will rest on the walls. Or if they're tired, they will rest on walls. Sometimes mosquitoes outside would like resting on indoors in houses, and they will rest on walls. So with indoor resting collections, what we do is we go to houses and we'll tell the house, we get permission from them, and we try and go early in the morning, because usually mosquitoes enter the house and some of them leave before the morning and some of them will leave as soon as it starts getting bright. So we want to get there right when it starts getting bright. And it's very irritating to the people who live there, because we wake them up and we move things around. So the idea is that mosquitoes resting around the house and we want to capture them all. So how do we capture them? So the first thing we do is we enter the house, we close all the windows, we close all the doors so they can't escape, right? Then we take everything that's sort of sitting around, like bottles and things, and we put them aside because we don't want to break anything. It's someone else's house. And then we lay white sheets on everything, across everything. So anything falling down will fall on those white sheets. And we try and do this as quick as possible. So we close all the doors, move everything out of the way, place white sheets on top of everything, and then we take pyrethroid or a spray can of off, or whatever spray, insecticide spray is available there, and you spray it around the whole house, in the rafters, everywhere. So you create this cloud of insecticide there. Then you quickly leave the house and shut the doors. So you basically have sprayed this whole house with poison. That would affect your mosquitoes. Now, what happens in those 10 minutes? All the mosquitoes that can be affected by it will fall down. Other insects will fall down, and they all fall on your white sheets. After 10 minutes, you open your doors, you open your windows, you carefully fold your white sheet and you take it out and you lay it out on the ground. And what you see here is a person laying out the white sheet and collecting all the mosquitoes that have fallen down. And let's say you catch 23 anopheles. The PSC has told us that there are 23 anopheles resting on the walls of that house in the morning. I hope that explains it. And this is important to understand IRS, right? Indoor residual spray. You can understand that at least 23, those 23 mosquitoes might be impacted by IRS if they rest on those walls. Those 23 mosquitoes do not include the mosquitoes that might have come in and left.
Thank you, Neil. Thank you for that. Wulan, did you have your hand raised? Any particular reason you had your hand raised?
No, just sorry, just accidentally, but I also want to say that for participants that want to get the recording, please just access the website, because we cannot send the recording one by one to your email. Thank you.
Okay. Thank you.
Thank you, Wulan.
Yeah. So we went through larval surveys, right? And when we're looking at optimal mosquito collecting methods, the first thing to ask is, what is your question? We will come back to that every single time, and I hope you keep saying that. I think all my students and people who work with me get really irritated with me because I'm always like, so what is your question? Because then we can actually focus. Then what mosquito behavior do the available sampling methods take advantage of, right? You saw all the different sampling methods. Each one of them takes advantage of a different behavior, slightly different behavior. What are your indicators you're collecting? Of course, that would tell you what sampling method to use. You also have to figure out how your local mosquito vectors behave with your trap. And I'm going to go over this in another slide set, I think, in a bit. Because as I mentioned earlier, different mosquito species have different behaviors, but your local mosquito species, the same mosquito species, will have different behaviors in different areas. Brats, I hate them. They make everything so complicated. So traps have their pros and cons, and it's important to pick your trap based on your question, based on the indicator you want to collect. Here's an example of why mosquitoes vectors behave differently with a trap. This data is also from Indonesia. I used a lot of data from Indonesia because I'm here right now. You can see each of these is a different site. This is in Lampung, this is in Purworejo, this is in Halmahera. On the left is indoors, on your right is outdoors. So the white is indoors and the gray is outdoors. Each one of these, this is an HLC, this is a CDC light trap, ITT, resting box, it's the Ifakara 10 trap. So you can see we trialed 5 types of traps indoors and the same 5 types outdoors in all these sites. And you will notice that in each of these sites, we caught different numbers and types of mosquitoes. For example, in Lampung, the HLC caught the most mosquitoes indoors and slightly more outdoors. In Purworejo, the Indo HLCs didn't work at all because your mosquitoes like biting outdoors. We caught them outdoors mostly. And in Halmahera, I remember sitting out for 3 weeks with my legs hanging out there, trying to tempt a mosquito to bite me, and I didn't catch a single one. The second we put a goat out, we caught a bunch of mosquitoes. And Halmahera was our high transmission site, which is crazy to think about, right? You have a high transmission site and your mosquitoes are not biting humans. And that is because if you have enough of a population of mosquitoes that's high enough, even though a small proportion of them are biting humans all the time, that's still a lot of transmission, even if they don't prefer to bite humans. So trap efficacy, how well your trap works, is location-based. It's based on their behavior. And the sampling method you use can completely change your data. Just imagine on the left, if I used a goat to understand the biting behavior in Lampung or Purworejo, that would not work really well. But if I used a human indoors to understand the biting rate in Purworejo and Halmahera, that would also not work very well. So your sampling method you use can completely change your data. And I've seen this in almost every single study I've done. So we've done trap evaluations in a whole bunch of sites, and it's crazy to think about this, but every single site, every single trap works differently. It will drive you crazy because it's already driven me crazy. Yeah, so it's important to understand how your sampling method works to collect the indicator appropriately to answer your question. Here's an example of how ideal and proper trap selection or answering your question actually got us the right data. So this slide is a bit sensitive, but I'm going to present it anyway. So what happened was that this specific country, whose name I can't mention, wanted to figure out if their mosquitoes were resistant to an IRS insecticide. So they did what WHO says to do. Do your larval collections and do insecticide resistance tests, and they found low resistance to deltamethrin. So what did they do? They found low resistance. This is really, really great. Let's implement IRS with deltamethrin. And they did that. And malaria went up. Malaria went up. And they're like, ah, what's happening? And so, sorry, my high-pitched voice made me cough. They're like, what's happening? And so they're like, can you try and figure out why, even though most of them are susceptible, why did transmission go up? And so we went in and selected specific sampling methods and asked specific questions. So our specific questions were, what species are impacted by IRS? What proportion of our mosquito population is impacted by IRS? And what we looked at, the indicators were the indoor resting density, we looked at insecticide susceptibility, and we also wanted to see what the biting rates were. Did IRS impact your biting rates? And what we found was we did outdoor HLCs. We found 2 species. Both of them were susceptible, species 1 and species 2. And I'm like, great, these 2 species are biting outdoors, they are susceptible. We did indoor HLCs and window exit traps. And what we found is species 2 was biting indoors with the indoor HLCs, but species 2 was going inside and leaving before the morning. They were not even resting. Species 2 was not resting indoors. They were just flying in, biting, and leaving. They're like, I got my food, I'm going home. I'm going outside. And so species 2 was biting outdoors, they were susceptible. Species 2 was biting indoors but not resting, and they were susceptible. So that means species 1, this population was not being affected by IRS. This population was not being affected by IRS. And this population was not being affected by IRS. Now let's see what happened with PSCs. With PSCs, which is indoor resting, we found species 3, which was resistant. And they were biting indoors as well. So what was happening is a species 3 was flying indoors, feeding on people and resting on walls, and they were resistant, which means IRS is not going to be effective. And species 1 and 2 were feeding indoors and outdoors, but the ones that were going indoors were not resting and just flying straight outdoors, which means that they were refractory to the intervention. And all of a sudden, we understood why deltamethrin, with low levels of resistance, because species 3 was actually the smallest population of mosquitoes, was actually not that effective. So asking your question appropriately, picking your sampling methods, you could see indoor and outdoor HLCs with PSCs, is so important in how you answer your question, if you can answer it appropriately. My last few slides, it's important that when you're using multiple sampling methods to make sure that they don't interact with each other. For example, if I'm doing a PSC in a house, I'm spraying that whole house with insecticide, right? The following day, if I do an HLC in that house, there might be leftover insecticide, which means mosquitoes might not want to enter that house, and that will impact my HLCs. Also, conversely, if I say I'm going to do HLCs in the night and in the morning I'm doing a PSC, all the mosquitoes I catch in my HLC will not rest on the wall and will not be found in my PSC. So we want to make sure that our sampling methods do not interact with each other, right? Because we want the best data possible. Well-designed sampling methods can obviously answer more than one question. For example, HLCs can look at species composition, hue and biting rate, can look at seasonality, can look at indoor biting rate, outdoor biting rate. But HLCs cannot look at indoor resting rate, obviously, right? Because that's a completely different, that sampling method does not function on those endpoints. If you look at the ESPT on page 20, table 8, you can actually look at the sampling methods listed out here. You can look at the mosquito behavior that sampling methods take advantage of. You can look at the host preference, and then you can see over here. So if you don't have experience at all these sampling methods, and if you have not used them, we have got a bunch of experts together and thought through this process. Is the sampling method appropriate to collect data for these indicators? And now here are the minimal essential indicators, and here are supplemental indicators, and it says yes or no. The blue-green color indicates yes, you can collect those indicators. And here are examples of the sampling method. So we have thought through this for you. So if you have your question, if you have your list of indicators, now you can map it onto the sampling methods and see, can I use these sampling methods at our site? So we've already thought this through this for you to make it easier. If you look at table 9, which is on page 21, this looks at the positive things and the negative things, the limitations and disadvantages of each sampling method. So we have the sampling method listed out here. So if you have never used a sampling method and you have no idea if it's easy to use or not, reference this table and you can see if it requires standardization, if the condition of the samples is poor, if it's really good. Are the samples alive at the end? Because suppose you want to use them for something, right? Can you use this sampling method to collect an indicator to understand if bed nets might be appropriate for my site? Can you use this sampling method to collect an indicator to understand if to evaluate that intervention at my site? Because these are two different questions, right? This is the potential of an intervention. This is an evaluation of an intervention. So you can actually map out your indicators to your sampling method, to your question based on this table. We've thought through it for you, so you don't have to do that. So there's a slide on lab analytical techniques. That's in box 2. There are multiple types of analytical techniques that you would do in lab. For example, mosquito morphological identification, PCR identification, salivary gland dissections, ovary dissections. You can look at all these things in lab. One thing on here is wrong. And normally I'd ask you all to figure out what we have to correct here. And it's PCR for parasite detection, PCR to understand sporozoite rates. And that's because your PCR looks at DNA. It does not look at infectious parasites. So for example, if there's a mosquito that took a blood meal on me and I had malaria, its blood meal would have parasites. And even though I would squish up only the head and thorax, they are going to come out positive. There's a publication on it. They're going to come out positive. So you're looking at infected mosquitoes and not infectious mosquitoes. There's a difference. Does my mosquito have malaria in it? Or can that mosquito transmit malaria? So number 7 is actually wrong. Parasite detection is sort of right. We're looking at the parasite in there, but it's not looking at infectious mosquitoes. So when you're looking at optimal mosquito collecting methods, what is your question is your first thing. What is the behavior the trap takes advantage of to collect the correct indicator? And I would validate the sampling method with your local mosquito vectors. Make sure that it works well with your local mosquito vectors. And that was my last slide for today. I assume there are way too many questions.
Bang on time. My goodness, 1 minute to the hour.
I tried.
And you did well. Well done. So again, I think on behalf of the audience, I think you will agree with me, an excellent, highly instructive, highly enjoyable session. And we all thank you for that, Neil. Loads of very valuable information that you've shared with us. And we appreciate that. So, Neil, I wonder, do you feel like taking maybe 3 or 4 questions?
Sure.
And then we'll
Yeah.
pick up the rest.
Yeah, since
But can I just ask the audience? Apparently, there are quite a few people that are asking for the slide decks to be sent to them individually. I'd like to ask your understanding, please. You know, it's not that easy. It's far easier for you to go to the website that Wulan has put up on the screen multiple times, I think, or in the chat box. So please, I ask your understanding. Please visit that website, and you can access the entire course material that Neil has presented. It's all there available to you. But perhaps even more importantly is to access those ESPT tools, the documentation that is also accessible from the web, and Neil has listed those websites. I think if I recall, it was ESPT EMI, and just plug that into Google and it should come up. Neil, can you confirm the website?
if just Google MEI,
MEI,
Malaria Elimination Initiative, and ESPT, MEI and ESPT, and it should pop up. Yeah.
All right, over to you. Thanks, Neil. If you have a few minutes just to go through just a few of those questions, that would be great.
Since you looked at them, do you have any that stand out?
Neil, they're kind of all similar in terms of general relevance. Maybe.
So here's a couple of questions. Do we have to carry out the indoor resting catches in a single house or multiple houses to get a better picture of mosquito bionomics? This is a great question that actually asks about sampling. Like, how much sampling should we actually do? What is our sampling frame? Should we do 1 houses or 20 houses? And this is so dependent on your budget and your capacity. And I have a couple of slides about this tomorrow, but the key point is we want to make decisions based on good data. And we want our data to be representative of what's happening in our geography, right? So how much sampling is representative of what's happening? And that is a thing that like global bodies haven't really talked about yet, but we are trying to find this out and trying to look at methodologies to look at it. And I'm actually trying to work on it right now. And I had in a couple of presentations tomorrow or day after tomorrow, I'll talk about how I'm going about it. So potentially you can go about it, or we can all possibly collaborate on a global initiative trying to find out, oh, that's an idea, trying to find out what is representative sampling. That might be some that can be an output of this training. Another question is,
Neil, is there a molecular method that can be used to identify infectious mosquitoes instead of infected
yes.
mosquitoes since the, yeah. So, you know, you want to know sporozoite rate. So what method should you use?
So the standard way of looking at infectious mosquitoes is ELISAs. ELISAs that look for the proteins that are actually present on the infectious parasite. You're right, there's a difference between infected and infectious, and it's more important to know the infectious. ELISAs are the standard method used. Correct.
Here's another one. Thank you, Neil. Can you elaborate on an appropriate sampling strategy to be adopted during outbreak situations for an entomological investigation? So appropriate sampling procedures during an outbreak event.
Okay, so when you're looking at an outbreak event, actually there's a decision tree for this in the ESPT. If you've downloaded it, look at that. But for an outbreak, your main thing you're trying to do is, first of all, treat people, find people who are infected and treat them. And the second thing to do is trying to implement an intervention that works as well as possible and prevent further transmission. And I would do a quick evaluation as quickly as I can of where and when mosquitoes are biting to understand where transmission events are happening alongside human behavior, as well as indoor resting. And based on that, you can see the proportion of mosquitoes that are biting indoors, proportion that are biting outdoors, and at what time. So you can figure out how well bed nets work and give everyone bed nets if that's going to be effective. And the proportion that of the total proportion, the proportion that are resting on walls, and then implement IRS as quick as possible to see if that can impact transmission the most. I hope that was a quick answer. I just used WHO recommended interventions as an example.
Yeah, no, great. Neil, so there have been a number of these questions related to human landing catches.
Yeah.
And it is an issue because HLC is the gold standard, as you pointed out. And, you know, the second best doesn't come, you know, very close to answering the question, which mosquitoes are biting humans and in what numbers? So the question is, essentially, are you still using HLC routinely? How do you work around these ethical concerns? You know, there's no way of working around the ethical concerns. Either you're allowed to do it or you're not allowed to do it. If you're not allowed to do it, and I know you've explained it, maybe just briefly suggest some of the methods that can be used as a proxy instead of HLC.
So Leo's right. If you can't use it, you can't use it. So what can you use instead? So the standard one that people use are CDC light traps. It would be really great if you had an evaluation of CDC light traps alongside HLCs to be able to understand the conversion rates. For example, 1 mosquito caught in a CDC light trap is equal to 2 mosquitoes caught in an HLC. So you can convert that to HLC rates, HLC landing rates. Other methods are human baited traps, where the mosquito is attracted to the human, but somehow or the other, you can capture that mosquito without it biting the human. There are a couple of traps. One of them is the human baited tent trap. Then there's the Ifakara tent trap as well, and the host decoy trap as well. A lot of the times, these are very inconvenient to use indoors because they're kind of big. They have to fit around a person. So, and in small huts, they're really hard to use. And when you put them in a house, you basically change everything that's going on in the house. So they are more difficult to use, but those are alternatives that are possible. Yeah.
So last question, I think, Neil, because we're running over time now, is an interesting question from Dr. P.T. Joshi. Thank you, Dr. Joshi. Good to have contact with you. And it relates to the issue of, if you do a pyrethrum spray catch, in some houses or in some areas, you'll find a lot of blood-fed females and so on, whereas in other places, not so many. How do you interpret, what's the meaning of a high number of blood-fed females versus low numbers of blood-fed females? Can you say something about that?
So the mosquitoes will be resting in the house in the morning in PSCs for multiple reasons, right? One of them is that they flew into the house, found a blood meal, and were so full and fat with blood that they couldn't fly really far and just wanted to rest a minute before, rest a couple of hours maybe before flying out. So those mosquitoes you would catch that are blood fed. The unfed ones now, those may represent multiple behaviors or situations. One of them is that the people were protected by bed nets and they couldn't access the people, and they're flying around, got irritated. Maybe they landed on the bed net and got exposed to insecticide and they were resistant. And then they were like, oh, I need to rest for a minute because I'm not feeling well. And they rest on the wall. Maybe it's just that they couldn't access a blood meal. Maybe the house was humid and it was nice and cozy and they were flying around outside and like, I need a place to rest. And that looks nice. For example, in some sites I found in Off Vegas, that don't like humans rest a lot indoors. The highest proportion of indoor resting mosquitoes were Vegas at that site that did not feed on humans. They fed on cows. So they could just find a place to rest, and that could be indoors. Multiple reasons. But in the end, what we're trying to do is understand what proportion of mosquitoes would be impacted by IRS. That's the main point for doing indoor collections and PSCs. So we can look up we can do sub-analyses of the proportion that fed on humans, a proportion that didn't feed on humans, a proportion that hadn't fed at all, and trying to understand the situation better. I hope that sort of explains.
Yeah, no, thank you, Neil. So again, audience, thank you for your patience, for your interest. We appreciate your attendance. We've got another session to look forward to tomorrow, and I'm sure we're all going to enjoy it as much as we did today and yesterday. Again, a very strong attendance rate today. It shows sustained interest, and that is great. And it reflects on the quality of the lectures that Neil is giving us. So on behalf of all of us, Neil, thank you so much again for what you're doing. My thanks also to Wulan and Dr. Porn, quietly working away in the background to make sure that the Zoom platform is running smoothly. All other glitches are attended to. So to everyone, we'll see you tomorrow, same time. Thank you very much. Thank you all. Thank you.
Have a good evening.
Thank you.